Okay. So in the second half, yeah. In the second half, we're going to talk about paradigms of machine learning, which is the other content that I want to go through with you today. Okay, we don't have a lot of time, but we're just going to try to get it through it. Okay, so we're going to look at three different paradigms of machine learning in this course. Okay, there's the supervised type of paradigm, unsupervised, and reinforcement. So I want to introduce this distinction of what types of data we use for this. Okay. So supervised learning is very, very simple, right? You're given some x, right, which we've talked about, right? Some vector x. You can think about this cat or this dog image as a vector, right? It's basically, right now it's a matrix, but you can take out each row and lay them consecutively after each other, right? So you have a very long vector of pixels. The pixels have values, right, RGB, so you can say each pixel is actually a free tuple of values, okay? And I'm going to take this very long vector of numbers, and then that will be my x, okay? And my y is just this thing over here, okay? Cat or dog, okay? So now it's a binary classifier. I have to decide whether an image is a cat or a dog. Simple as that. So when we say we're talking about supervised machine learning, it just means that I have an answer for it, okay? In addition to the x vector, I'm given the y scalar value for it. All right, so either +1 or -1 in this case. Okay, so this is going to be the bulk of our course that we're going to talk about, which we'll illustrate through our schedule. Right. So when you look at our schedule, in fact, next week we'll be talking about some fundamental concepts in learning. Okay, and then for the first week 3, week 4, week 5, week 6. Week 7, week 8, week 9, week 10, all of these are supervised learning topics. Okay, so very important things. Okay? All right. So in supervised learning, as I said, it will make up the bulks of our course from weeks 2 to 10. All right? So I promised actually at the start of the second half of lecture to introduce some of our staff to you. I neglected to do that, so I'm going to do that right now. So sitting in front here are 3 gentlemen. They are post-grad TAs for the course. We also have 10 undergraduate TAs helping with the course. There's Ma Yushan. Yushan, can you stand up? Okay. He's our tutorial coordinator. That does not mean he addresses which tutorial you get. Okay, that's another group of TAs, which I've also talked about on the Coursemology forum. But he's the one who will be in charge of all of the tutorial content, their solutions, and any errata that come out of that. So let's give him a round of applause. So you can reach him at Yushan Ma at NUS EDU. He is a student in Tra Tat Seng's group, the multimedia group at NUS. SOC. They do so many different things. So if you have interest in multimedia like computer vision and other types of things of sorts, multimodal, then you can talk to Yushan about his research interests. Okay. Next we have Mohammed Nimo. Nimo, can you stand up? So Nimo has been through this course before. He's seen all the problems that we've had with Google Colab and doing the exercises for it. We still have problems writing up all of the notebooks for you to do, but hopefully we'll have a much smoother time this year. So he will be in charge of all of the things related to Coursemology assessments as well as Google Colab. Okay, so if you have any questions about those things, ask him. Okay, his email address is nimo@unus.edu. He's in Wang Lim Soon's biomedical research lab, so he does applications of traditional machine learning mostly, but also some deep learning for biomedical applications. Okay, and finally we have Shi Ziwei. So as you all know, you have to do your projects. So the projects are worth, as I've told you before, about 30% of your grade. He will be the one in charge of doing all the routing for things here. Okay, in particular for projects, as you will see in the videos that I've already posted online, you're going to do peer grading. Okay, so that means part of the parts you have to receive project proposals, final posters, and videos from your peers in class, and you have to give a component of grading for that. Ziwei will be writing all the software and debugging it and testing it and sending you annoying emails at night to make sure that it's done on time. Okay, so hopefully we have these free, dedicated personnel to these free functions within our course. Okay. So coming back to the topic, now it's your turn. So please think about a short description, okay, maybe about one paragraph or so, 1 to 4 sentences. Again, write it here in Coursemology. Write it here in Google Colab. So double click it because you have an editable file. Okay, and talk with your friends. Okay, talk for 2 minutes and write down an answer for it. For this particular one, it's okay that you have the same answer. All right. So come up with a problem that would fit a supervised paradigm of machine learning and explain why it fits that. Okay. So actually, there's no better time to do your homework than right in class. This is what I used to do when I went to lecture. So go ahead and type in your answer. It doesn't have to be the final one. Just put a draft there. Flesh it out. You guys are going to discuss this in tutorial 1 anyways, in week 3, if you're a tutorial leader. Okay, while you're doing that, I'm going to just narrate, okay? Interestingly, when people think about deep learning, all these advances in machine learning that you hear about, many of them actually correspond to this paradigm, right? Using neural networks that are huge and vast in order to accomplish this simple task of engineering an h of x, right? Taking inputs, then spitting out a value. Okay, so we're going to learn more about deep learning in weeks 08 and 09. They're not typically part of the machine learning curriculum for, if you go to Stanford, not Stanford, but you go to many places in the world, and when you learn machine learning, you typically don't learn deep learning as part of it, okay? But because deep learning has had such a pervasive impact in machine learning, we have opted to take out some of the, more detailed math parts about the computational learning theory, etc., which are also really important, okay? But we've forsaken them in favor of giving you a little bit more of applied nature of this course by covering deep learning, okay? So we're going to do deep learnings in week 8 and 9 in our course, okay? As you can see from the second half, okay? Sorry. Over here. Deep learning in week 9, neural nets in week 8, so they'll be right after the midterm. But by then, it's probably too late if you wanted to do a machine learning project on that. So you could get started by watching some of these videos and other things early on. Okay, so I'll try to make those available if you're interested in doing a deep learning project. Okay, typically our class has about maybe 50 to 75% of the projects are deep learning projects. Okay. So anyways, I hope you got a shot of putting in something for question 4. Put it in your notebook, and then later when you're happy with it, transfer it to Coursemology. All right, so it's over here, right? Put something here. Okay. That was a pot shot. That wasn't very nice of me. Sorry. Okay. Now let's try to actually do some machine learning. As I said, you can just push some buttons and then you're doing machine learning. Woohoo! Okay. So we're going to do that. This, as I told you, is a Jupyter notebook that you've loaded in your notebook or laptop or pad or whatever. Okay. So we can use it. Okay. When you highlight code cells, right? You just press this funny run button here, right? Or you can use a shortcut, okay, and you run it. Okay, we're gonna go playground mode. Okay, run. Yeah, run anyways. I don't read any of these conditions anyways. Okay, so we're gonna run it. So what Google is doing is it's allocating a virtual machine to you, and then connecting some libraries to it, and then it'll run the code. So let me try to step through what it's doing. Okay, just in case you've never seen this before. So the green things here that start with hash marks. Let me just try to do this and see whether it's gonna work. Yeah. Okay. Okay. This one is a comment, right? So all these green lines here are comments. You can ignore those, okay? The other lines here are all programming functions. So I'm going to say, for example, first I'm going to take from a library called sklearn, scikit-learn. I'm going to import something called datasets. So this is just a bunch of data that people like to use for toy problems, for illustrating learning concepts, okay? So it's going to import some functionality, that's what line 2 does, okay? And then line 5 here is actually going to take a variable digits and assign it to something that is going to be loaded in by this function. So this dataset utility, this library has a function called load digits, and load digits just basically imports some data into this digits variable. Okay? Now, the digits variable is basically a large data matrix. Okay? It has both the x and y values, but we only want to put the x's in the x part and the y in the y part. So what we're going to do in lines 8 and 9 is separate them. Okay, so I'm going to call a new variable x underscore digits. I'm going to declare it and then assign it some data, which is the digits, the data part of it. That means the big capital X part of the matrix. Okay, rows of rows of rows of rows of instances. Okay, these actually happen to be pictures of handwritten digits that people wrote. Okay, so we're going to have these long vectors representing some grayscale information about that. Okay, you're going to store that in a variable called x digits, and the actual digits themselves, like whether they're 1 or 2 or 3, we're going to store in digits.target. So this is going to be a column vector, this y vector, okay, that has all of this information about, for each x vector, which digit is it? Is it 1, is it a 2, is it a 5, okay? And we're going to find a number of instances in our data set by just calling length on this, okay? And then printing that out, and then look at a particular input value. So I'm going to look at, for example, the input 1, and then tell me what label it was, okay? So from here, you can see that this particular data that we've loaded has 1,797 instances, and the input looks like this. So what the heck is this? Okay? These are grayscale values between 0 and some large number. So what 0 means white. Okay? Some large number, let's say 13 means, I think it's out of 16 means black. Okay? So what you can see here is a row. Okay? This is actually 8 by 8 pixels. Okay? 1, 2, 3, 4, 5, 6, 7, 8. That means the top row is mostly white, but in the middle it's a little black. Okay? And then you've got it's basically 64 values here, and that's the picture, okay? And it says that this was a 0, okay, whatever 0 is, okay? All right, and then we're going to do some more machine learning, all right? Are you ready? It's very simple. You go here, and you press run. Congratulations, you've done machine learning again, all right? So what did you do? Well, we set aside some of the data for training. Okay, so we took, let's say, 90% of the data, okay, in our data samples, and we said those are the ones that the machine learner is going to have access to learn the concept, okay? What is a 1, what is a 0, etc., okay? And then the rest of it, okay, the 10% left, those are going to be what I'm going to test against, okay? It's not fair to test something on things you've already memorized, okay? So we have to provide new data that's not seen to the learner in order to assess whether it's doing well or not, okay? Okay, so after I've done that, I can print out the number of training and testing examples right here, okay? 1,617 training examples, 180 examples, okay? Now we're going to do some more machine learning. Actually, what we did right now was pre-processing, so I'm sorry, you haven't done machine learning yet. Okay, so now we're going to do machine learning, all right? 1, 2, 3, go. Bang, we're done, okay? So that was machine learning. Congratulations, this is all of week 3. Okay, so what we did was we took a new library called neighbors, okay, from the nearest neighbor library. We imported it into our environment, and then we ran a particular instance of it. Let's get rid of that. Okay. So my library is not working quite well anymore, but basically we called that particular algorithm, which is called k-nearest neighbors, to learn the concept. Okay. And all the machine learning is done in this one function call on line 8. It says, take the data with the answers in the training data, so I know that image 1 corresponds to 0, image 2 corresponds to 1, etc. All of these 1,617 examples, okay? Learn from them by fitting a model. That means finding weights of theta or w, okay? In k-nearest neighbor, it actually doesn't learn any parameters, but we'll talk about that another time. Okay, and then use this model that you've learned to see how well you do. Okay, so I'm gonna actually run the test information, all the ones over here, right? All the test values, my x test with their answers, and I'm gonna grade the algorithm on how well it does on these examples it didn't see. Okay. Score it for me, store the results in a variable called Q05, and then print it out. So you should get this figure, 96% accuracy. Okay, that means given any one of the 10, all of the test examples, which were, let's see, numbering 180 of them, it got about 96% of them correct. Okay, so you can take this number, okay, copy and paste, okay, go to over here. Plot, okay, put it there, okay, save draft. That's my answer, okay? And then you can continue onwards, all right? Okay, so that's machine learning in a nutshell, okay? But we haven't done any of the underpinnings for it, but that's how you execute it. Typically, of course, as software engineers, we abstract things so easily that you just need to call one line of code here, the fit function, to achieve the machine learning outcomes. Okay. All right, so that was the first paradigm. When we don't have answers, then it's called unsupervised learning. So if I didn't know any better and I was a toddler, I can't speak to my parents yet, and I see these pictures of things that move, okay, then I'm trying to do this task of unsupervised learning. Now you may be thinking, what the heck can I do with data without labels, right? So I want you to answer that question, right? So that's question 6, okay? What can we do with this type of information, okay? In fact, unsupervised learning is a very, very important aspect of machine learning. In fact, if you look at how many things are out there in our environment that we don't get explicit answers for, it completely overwhelms the number of things that we have answers for, okay? So nobody sat down and told you that's a tree, 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 okay? But you learned from data, okay? You were able to figure out that those things are trees, given maybe very few examples, okay? So somewhere along the line, you had built the concept of trees on your own, unsupervised learning, and then, you ask your parent, what's that green thing outside? You say, oh, that's a tree. Then suddenly you have a name for it. That's semi-supervised learning, where you take information from unsupervised learning and then you label it using supervised learning. Okay? So I'm going to ask you to do this. There's a cell hidden here. You can just click on that, okay, and then it'll tell you a little bit more, okay, but I'm not going to go over that right now. Okay? So the very final part of machine learning that we're going to have to do in week 12, okay? So let me just go back to our schedule here. Actually, we do cover unsupervised learning a little bit over here in week 11, okay? So we're going to be learning k-means and EM algorithm for doing that, okay? So we only have 1 week of that. And we have 1 week of reinforcement and adversarial ML, which will be in week 12, okay? And so you might be thinking, okay, so Min, what is reinforcement learning? It sounds like something that the Army general does. Okay, so what is reinforcement learning? The basic part is, it's a little bit more complex than that. It's about a sequence of states. Okay, so when you think about doing a sequence of actions, sometimes it can be something like reinforcement learning. So one part that you hear a lot about is gameplay. right? So for example, there was a while back when there was Google first announced that it had created an algorithm that can play, for example, Go or chess, right? Deep Blue. Okay. All of these algorithms learn how to play these games through reinforcement learning. And how they did this is very simple, right? They basically have a representation of a state, okay, which is again a vector of some sorts. And after this, that vector is going to help you decide what action to take, like what place on the board to put a piece, okay, something like that, okay? But that's supervised learning, isn't it? I have an input, I have an output. The difference here is that in reinforcement learning, what you do in one problem instance influences what happens at the next time point, right? So you can think about this as a series of different instances where you have to make decisions, okay? But sometimes we make actions and they don't have a consequence, right? So for your example, you play a game, you move to a bit to a left a little bit, do you get any extra score? Maybe not. Okay? So we don't always receive feedback about whether we're doing well or not based on an action. Okay? Sometimes we do, like for example, we win a game, then we get a lot of feedback. Okay, you did it well. Okay? And then taking those types of rewards that don't always come at each decision point, and then trying to array that into a learning problem becomes reinforcement learning. So when you think about things like AlphaGo, OpenAI 5, okay, and then other works in adversarial machine learning, for example, the creation of deep fakes, okay, those are all done using these techniques, okay? So that's all I'm going to go over with you today. Let me just close out with a couple final things, okay? So this notebook that I've given you is for all of week 1. Okay, so now you've finished everything that you need to do to finish the topics in this notebook. Okay, the rest of the problems are for your declaration of work, which I have covered already with you in the videos. Okay. So in the second half, okay, you will need to view the rest of the coursemology videos. Watch this particular YouTube video called 5 Tribes of Machine Learning. You're going to find it here. Okay, this one. Okay, watch this lecture and then you'll be able to answer the rest of the post questions. All right? When you answer the post questions, again, you can do it in your notebook, but then you can go to coursemology under the assessments. And after you finish the pre-lecture, you'll be able to do the post-lecture one. Okay? Then you can answer the questions that are in the corresponding notebook. Okay? Next week, again, because this is flipped classroom, don't come here, okay? You're supposed to watch the videos on your own. And if you want to come here to talk with me or some of our TA staff about any incidents, then come and find us, all right? See you online.